Hi everybody. We're going to be talking about maps and fields in these notes, and we've been talking about longitude and latitude and how we can use longitude and latitude to find our locations. And I want to show you now how we work with maps. And these maps are lots of these maps you may have seen before if you've ever been hiking or camping, but these are called topographic maps, and these are going to be very critical in learning a lot about an area, and they don't necessarily just show you elevation; they can show you other things. So let's get started. When we start looking at fields, fields are just a general term for anything that's being measured. So you can measure temperature, you can measure air pressure, you can measure wind speed, you can measure anything, elevation. So a general term for that is these are called field lines, or this is a field. ISO lines are very specific. They're lines that connect places of equal value. So wherever you are on this line, so you can see right here it says 100. Anywhere along that line, it's 100. 100 what? Well, in this case, we're looking at elevation, so it's probably 100 feet. It might be 100 meters above the ocean. So that tells you its elevation. And any place along that line is the same value. If we have field lines of temperature, that's going to be isotherms. And again, here's one of those prefix-suffix ways that we can learn about words and break them down. Iso meaning the same, therm means temperature. If you think of thermals or anything that has to do with temperature, generally it's thermos, thermostat, any of those things would be related to temperature. Isobar, now think about that for a second. You may remember it from 8th grade, but it's places that have equal pressure, barometric pressure, and that's where that comes from. And we'll talk about where that term bar comes from when we get into weather. And when we look at a map, it's just a snapshot of a particular area. And it may not be elevation, it could be looking at weather variables like the cloud cover or heat indexes, any of those sorts of things. These field lines, an important thing is these field lines don't just end at the end of the map. They can continue as at the edge of the map they would continue. So do you see how this one right here, this line goes around in a circle? Well, this line is probably going to be following that same pattern. And so off the map we could probably estimate and give a guess as to where that's going to go. And we could connect it. This one we don't know exactly where it's going to go, but it continues somewhere. So these lines don't just disappear. And these field lines never cross. That's a really important thing. So remember that when we're working on these field lines. These lines never cross one another. Because then what you were saying, if this is 100 and this is the ocean, which would be 0, then you would be saying that if this is 20, 40, 60, 80, if this line right here cut across right there, you would be saying at this spot, you're saying that the elevation is both 80 and 100 feet above sea level at the same time, and it can't be. You can't have the same two different values at the exact same spot. So that's when we're starting to look at these field lines. When we look at, excuse me, contour intervals, the interval itself is the contour lines are the lines that connect equal elevation. So just like isotherms connect places of equal temperature, contour lines connect places of equal elevation. The interval is the difference in elevation between two adjoining contour lines. So it's what we're going up by. So in this case, this was the ocean's at 0. So if this is 0, then this right here would be at 20. This next one would be at 40. This would be, the next one would be 60, and then 80, and then 100, and so on. The interval here is 20 feet, 20 meters. So that's the difference between the contour lines. It's what what you count up by. That's what they count up by. We'll do this part in class because I want to just show you a couple things, but you may be able to do it. So see if you can, you're going to be connecting places of equal value, so connect each of those of equal value. And we'll do that in class, some more of that in class. Now, you'll see these topographic maps, and there's lots of different symbols and things that we can look at, but what I'll do is I'll just point out a few things here, and when we get into creating some of these maps, it'll become more clear. So the scale measures the distance across the surface. So as you can see here, our scale is this right here. So if I have 2 points, if I have a point here, and a point here, I could take a little piece of paper, mark the paper, and then pull it over to the scale and check to see the distance between them. That's map scale. The contour interval, as we said, the distance between, or the difference between two adjacent contour lines, not necessarily the distance, but the difference between them. And streams, if you look at this map, this right here is a stream, and we'll talk a lot about what streams do as they cross these contour lines. But basically, when streams cross, they always flow downhill from higher to lower elevation, right? Water doesn't flow uphill. And the contour lines themselves bend or point uphill. And when I drew this, I should have probably drawn it a little bit more with a little bit of a V shape to these. So these should be really kind of a V shape as these contour lines go across that stream, they kind of point like that. So this would be white. So they point uphill. Okay, so they point uphill, and water always flows from higher elevations to lower elevations. The steepest place is where the contour lines are closest together. So on that map, it's on the left-hand side, or the west side of the map. That's where the lines are closest together, so that's where it's steepest. So if you wanted to go sledding, that would be the best place to go. Benchmarks are places where they state the exact elevation at a particular place. So benchmarks, an example on here would be, this shows the exact elevation of this hill. It's 120 meters. We see that this is in meters, that's 0, so this is 120. These go up by 20, so that's 20, 40, 60, 80, 100, 120, and that's 123, that spot, the highest part of that hill. The depression, so if you have a crater, let's say, you'll get these little harkature marks, they're called. They're little lines. The first depression is the same value as the previous contour line, and any other depression count down with the same interval. So I'll just go back here quickly. So if this is 100, this is 100 here, this would also be 100, this first line is 100, and this goes down by 20, so that's 80. So this just showing you that this goes downhill from this spot. And we'll talk more about that in class as well. I'll get you some maps and you'll have a chance to look at that. Islands, of course, the first contour line is always 0 when you're going around an island because you're at sea level, and 0 is where we're talking about where the land meets the water when we're talking about oceans. Not necessarily inland lakes, but oceans for sure. And the highest elevation, oops, sorry, I gotta scroll down here. Highest elevation is 1 less than the next highest contour line. So if, for example, the highest contour interval was 120, I would have the highest elevation would be 1 less than the next contour line. Because I don't have a 140 contour line, I'd subtract 1, so the highest elevation is 129. So in this case, if this line right here is 120, this is 120 right here, 120. The highest elevation any hill could be in here would be 139 because there's not another line. There is no line here that says 140. So because of that, we don't have the 140s. So the highest elevation it could possibly be is 139. And we'll talk about all this stuff in more detail, but I just wanted to give you that so you have that as a reference point to start our discussion on maps. So make sure you answer the questions in the survey underneath the video and submit that, and then you can get credit for your notes, and I'll check the notes when we have class next time when these are due. Have a great day.